Hey, Algebra 2. Tonight's Ed puzzle is not going to be the notes, the pink notes that I had you guys glue in class for second period. For sixth period, you guys won't get these notes. But if you're in second period and you glued this in, we're not going to do these notes. We're going to save those for another day. Okay, so what we're going to focus on is actually this page, or SOHCAHTOA, or sine, cosine, and tangent. And I'm going to show you how to do IXL. Because for tonight's assignment, you're going to be doing IXL. Okay, so you're going to be doing the special right triangles IXL, and you're going to be doing the trigonometric ratio, sine, cosine, and tangent. Okay, and we've already done the special right triangles. We did that in class. The trigonometric ratios, I kind of introduced that, but I'm going to explain that further and how to do it on IXL. Some of you guys can go jump ahead, but go ahead and watch the Ed puzzle. So go ahead and click on the link here, trigonometric ratios, sine, cosine, and tangent. Remember, you can find this on Google Classroom. Click on that, and then I'll take you to this page. Okay, so what we're going to be using is the notes that we started in class, and that would be these notes here to the right. Sine, cosine, and tangent, or so, ka, to, okay? So we're going to use that to figure out how to solve these problems. Okay, so for example, let's just focus in on the notes. If I had a triangle, and let's say that triangle is obviously a right triangle. It always is in this case. And this side is 31, this side is 35, and this side is 42. And I'm going to go ahead and name each angle in each corner. This would be A, this will be B, and this will be C. Okay, so if I want to find the sine of one of these angles, then I would use this ratio to figure that out. So if I go here, if I want to, let's say, find the sine of A. Okay, well, the sine of A, or angle A, is equal to the opposite side over the hypotenuse. So if we look here, here's angle A, right? As part of our example. The side up across from A is the opposite. So across from A here, it's 35. And that's over the hypotenuse, which in this case is 42. So the sine of A is equal to 35 over 2. But again, that's a fraction, and we could reduce that. And I could divide 7 into both of those numbers. So then the sine of A is equal to, let's see, 7 divided 7, and divide 7 here, I get 5 over 6. So sine of A is equal to 5 over 6. Okay, now let's take that same triangle and apply it to cosine. What's the cosine of that same angle? Okay, 31, 35, 35, not 32, and 42, A, B, C. Okay, now the cosine of this angle is the adjacent over the hypotenuse. Adjacent over hypotenuse. The adjacent is right next to our angle. So that would be this 31. So cosine here would be, of A, would be 31 over the hypotenuse, which is 42. And there's no number that can divide both into 31 and 42. So your answer is simply 31 over 42. Now let's take that same triangle and use it for tangent. Okay, now the tangent of A, that same triangle, is the opposite over the adjacent. Now remember, the opposite is across from the angle. Okay, in that case it's 35. And the adjacent side is right next to the angle, and that's 31. So then the tangent of A will be 35 over 31. So let's use that idea to figure out these IXL problems. Okay, so this first problem here to the right, and let's change the window so we can see side by side. Okay, so now we want to find the sine of A. The sine of A here. So the sine of A, I'm sorry, not sine of A, sine of H. H is here. Remember, the sine of H is the opposite over the hypotenuse. Opposite over hypotenuse. Well, the opposite of h is 56. So what I'll do, set up a fraction here, is 56 over the hypotenuse, which is 65. And then I got to see, can I reduce that? No, I don't think there's any number I can divide into both of those that's the same. So it's simply that. Okay, so now the next one, sine of s. Well, remember that's opposite over hypotenuse. So sine of s, 12 over the hypotenuse, 13. So 12 over 13. Awesome. Now I skipped ahead because I wanted to show you guys an example of a cosine. So right now I'm at, what, 28 points? Okay, so for cosine, again, remember it's adjacent over hypotenuse. Okay, so in this case, the cosine of c, the adjacent is right next to our angle, so that's 12, and that's over the hypotenuse, which is 37. And I'm pretty sure I can't divide a number to both 12 and 37, so there's the answer for that one. Okay, now in this example, it took me about 40 points to get to a tangent example. So now, with tangent, again, remember it's opposite over adjacent, or TOA, O over A. So opposite over adjacent, the opposite of x, tangent of x, opposite of x is 30, and the adjacent is the number right next to it, which is 16. And it looks like I can reduce that, so I think I can divide, let's see, what can I divide into both of those numbers? We'll do 2, so 30 divided by 2 is 15, and 16 divided by 2 is 8. Okay, and there's the answer for that one. Okay, here's one more tangent example. So now again, opposite over adjacent, opposite of t is 55, over the adjacent, but wait a minute, there is no number here. So that's where we're going to have to use our Pythagorean theorem here to figure out what that side is. So I know that 55 squared, zoom in a little bit, oops, not too much, 55 squared plus, let's call this side TS, because that's the side it is, that's the angle, the line is between those two angles, and then equals 73 squared. Okay, well now I know I'll have to subtract this 55 squared from both sides. So then TS squared is equal to 73 squared minus 55 squared. And I know I'm going to have to subtract these and then figure out the square root. So let's do that all at once on the calculator instead of doing one step at a time. So in our calculator, I'm going to do square root of 73 squared minus 55 squared. And that other side is 48. So that side we needed was 48. So we go back here, type in 48, and I don't think there's a number that goes into 55 and 48. So there's our answer. Okay? And that's how we do the IXL problems.